So last videos, we discussed what was going on in connectivity, why it is important, and what is on a more theoretical level, what's going on. Now, how is it implemented in reality? So this is what I'm going to go through today. What happened last time when we discussed what was going on? We said there was going to be somebody on the machine and somebody on the MES. In reality, that's not what's happening. There's no person actually in front of the machine looking at it. It's the machine itself that gives the information. So what's seeing if it's not somebody? Well, we have some sensors that see what's going on in the machine, and those sensors, they are the ones that have the job to collect the data. So I'm going to stick to a board that enters a machine for this example. Could be many things, but just for the sake of this example, it's what I'm going to take. So you have a board that comes into the machine, and the barcode gets read through a barcode reader. And that barcode reader now, it needs to output ultimately its information to the MES. So this is where it's very different in the PCBA assembly than it is in other industries, because in the PCBA industry, we don't have a direct connection of the data from the barcode reader to the MES. And there's very good reasons for it. PCBAs, it's just a lot of data that gets output. Every placement on the machine could be a data point. Every nozzle for every head could and they have all process data, multiple process data for everything. It's just a lot of continuous data. It will just completely explode the bandwidth of your shop. So what the industry has standardized on. Oh, and also one other thing to note that is also interesting in the PCBA assembly is that the rest of the industry is running on PLCs. While on the PCBA industry, all machines are PC based. So that's also very different because all of the communication protocol are different on PCs and on PLCs. It's just completely different architectures. So since you don't have a direct connection from the barcode reader to the MES, what's really going on? Well, that information from the barcode reader is actually processed by the machine. And it's processed with code in the end. And that's where the semantics layer gets involved. So at this point here, this is processed by code. And then the code will take in this barcode and it will fill some information in an information model. On the field, you may encounter some proprietary run most of the time, or otherwise you also have some standards. Some standards which are CAMX and CFX. So the CAMX information model would be an item work start. So this is where the barcode information would be located. On CFX, it would be work started. So two different information models that can get populated. Then it will get to a specific format. For CAMX, I will just say the CAMX route here, it would be XML, or CFX, it would be JSON. And you could have, if you have any other proprietary, it could be CSV, or it could be INI files, or it could be just lines of strings. There's many format possible. Then it will get through a protocol, the protocol layer. This is so that the data can be actually output externally. So for the protocol here, it's also just a CAMX protocol, which is actually based on SOAP, and yeah, it's based on SOAP. And on the protocol layer for CFX, it's going to be AMQP. But you can have any other protocol that is any other way of communicating. Maybe it could be RPC, it could be file, it could be REST, it could be a whole lot of things possible here at the protocol layer also. This is just two ways that the standard implemented. And then that data would get to the MES side. And the MES side, it has to do it the other way around. So it has to go through the protocol layer. This will be called the client. Now I give examples on that side. On that side, I'm just gonna call the technical term of what that part of software is when processing the data. Next would be the format. So this would be a parser, or maybe some would call it a deserializer for the information. The next one is an information model. So this would be a mapping where you would map that information model. And the next layer is a semantics layer. So that's actually just the source code. The source code also, like the other side. So this is how actually the data travel from one point to the other. And really what you would be encountering in the field is that for the layers, the protocol layer, the format layer, these are usually solved with some standard libraries. So anybody that has spent more than a day doing connectivity, that's not usually where the issue is. For the information model, you would need some sort of mapping to fill in the information model. Usually that's also, if you use a standard library for information model, maybe you already have all the classes required, and doing that mapping is not that difficult. And even if it's not available, usually that's not the biggest hurdle. But the semantics layer, this is what I want to get at and explain why that is such difficult compared to other layers. And it really comes down to the fact that source code in our industry, it's always proprietary. So you never have direct access to the source code to know exactly what's going on. So going back to my barcode example, the barcode example, the example I gave was if it has a failure to read the barcode because the barcode is damaged or something, then it output fails. So what's going on in the code when that happened? The sensor would probably send out an error, and then the source code would decide what's going on. So source code would say, okay, if I detect an error on the barcode reader, I will output fail in the information model. And that's really just one case, but the thing is, you have to know how the machine will react for every cases that can happen on the machine. And because this is hidden and proprietary, this is where the difficulty is at. So you never have directly access to the source code, so what can you do? Well, your options are really to rely on samples, documentation, a contact, like a technical contact at the company, or to have what we prefer at Cogiscan would be a partnership, a long-term partnership with the equipment vendor or the MES. So this is really what you can do, and the other one would be just the sheer amount of experience you have over the year with those machines. This would also help solve the meaning. On the MES side, to give an example here at Cogiscan with our track, trace, and control platform, we don't have this issue because we do provide the connectivity and we do have access to the source code when we do the connectivity. So if we have any question on how data is going to be processed to deliver feature on the MES side, we can just always look at the source code to know what's going on. So there's no proxies in between, like those would be proxies in between the source code and you. We have that direct access, so that makes it a lot easier. And that's actually what needs to be solved in the industry. So in the end, to have a connectivity that is correct and meaningful, you need to be perfectly aligned on the protocol, the format, the information model, and also the semantics. So there's different ways to achieve it. So considering there is multiple machines possible, then one way to do it is to have this as a standard interface on the MES side, and then every machine would build their own connectivity so they will align with the MES. Another way to do it is on the MES side. So you have multiple machines, they all have their own interface, and then you create one interface for every machine on the MES side. The only other option is if you ever have a disconnect between those two, because this is standard and this is standard, you can always just have a third party here. So you would have a third party that will translate all of those layers one to one. And that's really where the next question is. So if those are all your options, who should do the connectivity? Because somebody will need to do it, somebody will need to adjust. So what are the different options and what's the best way forward? So this is going to be the topic of the next video. I'll see you in the next video. Bye-bye.